Let's talk about the difference between kinetic and potential energy. So what is energy? It's the ability to do work, and everything that happens in this world uses energy. Most of the time we can't see the energy, but we know what it is impacting because it's everywhere around us. It's never created or destroyed, but it can be stored or transferred. So we can put it and hold on to it, and we can use it later, or we can turn it to a different form. Here's an example of energy changing forms, a ball being thrown into the air. At the very bottom, the energy is being built up as it goes upwards. At the very top, it's reaching the most potential energy and the least amount of kinetic. But then as it comes back down, all of that potential is now turning back into kinetic. So again, there's kinetic energy to potential and back to kinetic. So it's just changing what it is, but it's not going away. Here's some other forms of energy. Batteries. A battery's job is to store energy, but it has the potential to do something with it. And then when we apply it to something such as turning on a flashlight or moving an electric car or something, we turn that form into something else. Until that point, it's storing that energy. A car moves. The car is using the energy, its motion, but it stores the energy inside of gasoline, inside of the battery. So it's storing it to be combusted to create that motion. So a car uses a lot of different kinds of energy. Food, things you consume every day, have energy stored in it that your body uses to break it down. And all of our energy, our heat, our motion, all comes from our food. And of course, a sleeping puppy uses its energy, but it's also storing it to be used for later on. Remember, everything's made up of particles and they never stop moving. So everything is constantly having energy and moving. How is energy divided up? There are two big categories of energy, potential and kinetic. And we're going to really kind of classify and give you some chance to interact with this. Potential energy is basically the energy stored in an object. Potential just basically means it has the ability to do something later. It just doesn't have to do it, not yet. There are three main categories: elastic potential energy, gravitational potential, and there's something that we'll talk later on, which is chemical potential energy. So all of these are the forms of potential energy that we'll kind of cover later on, but just the fact that there is different kinds of potential energy. Some examples of this: a stress rubber band has potential to do something. Water falling down a waterfall has the potential. At the top, it hasn't fallen yet, but if water is being stored at the top, it has the potential. A yo-yo in your hand has the potential to fall. And a drawn bow has the potential to have the arrow go forward. Until you release the bow, the arrow does not move forward. Couple things to think about for potential energy. The higher an object is, the more potential it has. The more mass an object has, the more potential energy it has. So keep those things in mind when you're looking at what is potential. Does this have potential? If I can move an object higher, it has more potential. If I make it heavier, it has more potential because it takes more energy to move it. Look at a boulder which has the least amount of potential energy, and why. We'll call this boulder A, and we'll call this boulder B. Did you say boulder B? It took the most amount of energy to get it up the hill. Therefore, it has the greatest amount of potential energy. It took a lot of energy to push it to the top or even store it at the top. It has a chance to fall versus this one, which doesn't really have much room to go downwards. Which one has the greatest amount of potential energy? The rock or the feather, or the brick or the feather? Did you say letter A? You are correct. The brick has more because, again, like we talked about, it is heavier, it has more mass, therefore it has more potential energy. Changing an object can change its potential energy. If you want to drop an apple from the top of these three things, which will have the most potential? The skyscraper, the chair, or the crane? If you said A, correct, because it is the highest object. You can get the most potential energy up there. How does this rubber band have elastic potential energy? Can you just explain that? Where did the energy come from? We stretch a rubber band. Your fingers pull it apart. You add energy to that rubber band, so you stretch out the molecules within that rubber band. So you're giving that rubber band energy from your hand motion. When is the spring having potential energy today? Or B? Did you say B? That is correct. Because this has the most energy as you're applying it to the spring, pushing it inward. When you release your hand, the spring extends itself back outward. Here's the formula for potential energy. So a couple different ways of looking at it. First one, we'll talk about potential energy of gravity, which is basically mass times gravity times height. Potential energy of gravity also is force, or we call it weight, times height. So if I take someone that has two people go up on the Tower of Doom, they're going to the exact same height. Remember, the person that weighs more, that goes to the top there, has more potential energy. It means very similar to what mass and gravity kind of relate to. Okay? So this is formula 1. This is formula number 2 on potential. Here's a way to look at it. Okay? So here's a tool. See the triangle. So I'm going to show you real quick how to use the triangle. If I want to find the potential energy of something, I'm going to cover it up. So everything along the horizontal line is my equation. Okay? If I want to know the mass of something, I cover up mass. Now I have mass equals, because I want to know that, potential energy over gravity times height. So it's a way to use this. If I want to know gravity, again, it's deriving this, I take G equals potential energy over mass times height. So these are ways of deriving this so you can get any sort of answer. Okay? Here's an example of a problem. A weightlifter lifts 120 kilogram mass. Boom. There's the mass. From floor to a position above the head, 2.5 meters. There's your height above the floor. What's the potential energy expressed? So, gravity on Earth has a universal constant we call 9.8 meters per second squared. That's the number that it comes from. Okay? Basically what that means is how fast everything falls on Earth. If we take and we plug those three numbers, so 120 times 9.8 times 2.5, we get 9,240 joules. That is our answer. And just a quick offshoot, a joule is the unit of energy that we use. Okay, so it's this word joule. So what's the potential energy? Different derived formula of a 90 Newton boat before it falls from the top of a 30 meter waterfall. So again, remember our formula, potential energy. Now we're dealing with force. Remember there's that weight difference, so it's FW times H. Remember, if I get that fatter kid at the top of the tower, they have more potential energy, okay? So 90 newtons times 30 meters, right? Look down here, is 2,700 joules. Okay? If acceleration on a new planet is 5.2 meters per second, on a hilltop, 100 meters or 650 joules of PE, then what's the mass of the meteor? Remember the triangle, right? What goes on top? Potential energy, mass, gravity, height, right? We want to know what is the mass, so we eliminate mass. So mass equals potential energy divided by gravity times height For us to do that, so potential energy is 650 joules divided by gravity, remember 9.8 meters per second squared, times the height of 100 meters. So 650 joules, 9.8 times 100 is 980. And our answer comes out to 0.66 grams. No, it's more of a kilogram, but okay. That's how we do it. But I also want you to understand that potential energy can be converted to kinetic. Remember, energy can be changed. So, when stored energy begins to move, the object now is changing from potential into kinetic. Some examples. You ride to the top of the hill, you slide down the hill, you're turning that stored potential because of height into kinetic energy of skiing or sledding or going down the hill. Running, riding your motorcycle, even slipping and falling. The faster an object moves, the more energy is produced. The greater the mass and speed of an object, the more kinetic energy there'll be. So again, there's a difference in what I want you to look at. Which object will move? These objects move at the same speed, which will have more kinetic energy. Is it object A or object B? The answer, definitely object B, because again, it has more mass. They're both moving at the same speed, but it has more mass. Therefore, it has more kinetic energy. An object has the most kinetic energy when its movement is the greatest. When it is moving the fastest, it has the most kinetic. An object has the least potential energy, it has the most kinetic. So when there's zero potential, it has all kinetic. Water bottle's knocked off a desk. When does the bottle have the most kinetic energy? Is it at the top of the fall, the middle of the fall, the bottom of the fall? Did you say C, the bottom of the fall? Because again, it's at the least amount of stored, but before it hits the ground, it has the most kinetic energy. Here's the equation to calculate it, okay? Kinetic energy is mass times velocity, okay? But the way to write it is it's mv squared divided by 2, or it's written as mass times velocity divided by 2. Okay? So let's do an example here. What's the kinetic energy of a 120 gram object at 30 meters per second? So again, meters per second is our velocity, and this is 120 kilograms. 120 kilograms times 30 meters per second squared. 30 times 30, so 30 times 30 is 900. 120 kilograms, 1/2 of that is 54,000 joules. Okay? Which one has the highest kinetic energy? Which one has the least? So, you have these two running the same speed, and these two have a different speed. So which one has the highest kinetic energy? Which one has the least kinetic energy? The highest kinetic energy definitely would be because of mass and speed, the semi. The least kinetic energy would be the motorcyclist because he has the least mass and then the least speed. Here's the equations again. ways to derive it. Okay? So kinetic energy is 1/2 mv squared. Here's some examples on a roller coaster. When does the train on the roller coaster have the most potential? At the very top. The higher the train is lifted, the more potential energy there is. As the train accelerates down the hill, it turns into kinetic. There's very little potential energy at the bottom of the hill, but there's a lot of kinetic. That's why you're going the fastest at the bottom of the hill. When does a train on this roller coaster have the most kinetic? And is it moving the fastest? Are you moving the fastest at the top or at the bottom, right? So then here's a little animated roller coaster to interact with. So here's a practice problem. Let's give you a chance to see what you come up with as your answer. All right, let's see what you got. Potential energy. So if we just work this through, okay, PE is mass times gravity times height. What we know our mass is 100 kilograms. Gravity is still the same constant. Our height is 50 meters. So we plug all that in. Mass of 100. Gravity of 9.8. Height of 50 meters. So 100 times 9.8 is 980 times 50. That's not a time symbol. Our answer comes out to be 49,000 joules. Did you get it right? Let's try another one. A 70 kilogram rock is falling at 30 meters per second. What is its kinetic energy? Okay, let's work it out. Kinetic energy is 1/2 mv squared. Okay? So our mass is 70 kilograms. 1/2 times 30 meters per second squared. Okay? So 30 times 30 is 900 times 70, 1/2. So again, system of equations. So 35 times 900. Our answer for this is 31,500 joules. Try another problem. A 315 kilogram object sets the top of a 50-meter building. What's its potential energy? Okay, let's check your answer. PE equals mass times gravity times height. Mass is 315 kilograms times gravity of 9.8 meters per second squared times its height of 50 meters. Multiply that together. Our answer is 154,350 joules. A car has 3,600 joules of kinetic energy and is going 3 meters per second. What is its mass? Okay, so our equation for mass is 2 times kinetic energy divided by m squared.